In this session, we are going to talk about polymorphism. Polymorphism is one of the four fundamental concepts of object-oriented programming. So it is again one of those concepts which makes Java such a strong language. So in this session, we will understand what is polymorphism. We will go to understand what are the different types of polymorphism, and we'll see how do we achieve it. So starting with what is polymorphism. So if you're asked to define polymorphism in Java is a way in which we can perform a single action in different ways. Let me write it down. I can say that polymorphism in Java is a way by which we can perform a single action in different ways. So if I try to break this polymorphism, it is made up of two Greek words which we call poly and morphs, where this means many and this means forms. So what happens many times in Java is that a single action is performed in different ways. So polymorphism means many forms. So here we will go on to discuss how do we achieve polymorphism. So polymorphism is achieved broadly by method overloading and method overriding. So the two ways in which polymorphism is achieved in Java is method overloading and method overriding. We will talk about each of them. We have discussed method overriding to a great extent in inheritance. We will just have a quick review in this particular session. Method overloading is very much on the concept of constructor overloading that we saw, but still we will discuss these two. After this, we discuss these two, we will go and talk about the two ways of polymorphism. So polymorphism can be divided into compile time polymorphism or runtime polymorphism. Again, we will discuss the difference between the two, and in order to understand compile time and runtime polymorphism, we will try to understand static and dynamic binding. So I have written three things here. So these three things forms a very important interview question, that what is the difference between method overloading and overriding, and what is compile time and runtime polymorphism, and what is static and dynamic binding. And obviously, in order to give the differences between the two, you need to very well understand that what is happening, what's happening in method overloading, what's happening in binding, and what's happening in compile time runtime polymorphism. So we'll start our discussion with understanding these two concepts, method overloading and overriding. First of all, we will try to understand method overloading. Now let's talk about method overloading. So first we will try to understand what is method overloading in Java, and then we'll see why is this feature important. So if I try to define method overloading, I could say that if a class has multiple methods having same name but different parameters, then the situation is known as method overloading. So I'll try to write it. So if a class has multiple methods having same name but different parameters, it is known as method overloading. method overloading. So I'll give you an example so that you can understand it better, that what's happening here. What do we mean by multiple methods with having same name but different parameters? Let's say we have a class called overload example. So we'll take a method name add. Okay, so this is a case of method overloading. So what do we have? We have a method add. So there is a class overload example. There are more than one method with name add. So the name is same, method name is same. What is different? Parameters. So we can see that let's try to understand that what is different in the parameters. So in between these two methods, the number of parameters are different. So in this case we have 2 parameters, in this case we have 3 parameters. In this case the number of parameter is same as this, but the data type is different. As you can say, this is float and this is int. So in this case we have 2 parameters but data type is different. So when I say that a class has multiple methods with same name, so we have multiple methods with same name add, and we have different parameters. So the parameters, make sure you listen to this, the parameters could be different in terms of number of parameters and also data type of parameter. So if the number of parameters is also different, then I'll say that the parameters are different, and also in case the data type of the parameter is also different, then these two methods are different. So in this case it is integer a, integer b. In this case it is float a, float b. Sorry, float a, int b. So these two methods are considered as different methods. So again, names are same, but the methods are getting differentiated based on the parameters. So this is an example of method overloading. So now we will go on to understand that why do we need such scenario, and we will also understand that how Java knows that whether I have to call this add or this add or this add. So basically how this method is getting called by the compiler based on the parameters. So first let's try to take a real life example. Let's take another example to try to understand why do we need a method overloading. By the way, I missed R in this spelling. So this will be overloading. Okay. So let's try to understand with another example. So we have seen a employee class till now. And we have seen that the employee had a method called calculate salary. So let's say a particular employee is getting the salary just on the basis of base salary. So in this case, my parameter will be int base salary. So, and I will simply return, let's say whatever I get the base salary into 2. Okay. Now let's say there are a set of employees who are getting bonus as well. So we will have public int cal salary int base salary plus comma float bonus. Okay, so in this case let's say my calculation goes something like that: return base salary plus 2 into bonus. So now let's say an employee has taken some leaves. So based on the number of working days, the salary is calculated. So in that case, we will have public int cal salary. Again, we'll have the base salary, comma, int number of working days. So let's say I do it something like that. So let's say this is the number of holidays the person has taken. So I can simply do return base salary minus number of days into 100. So now what is happening, that these are three different scenarios. Okay, so based on the different scenarios, I'm doing the calculation. Now you will tell me that why not to have different method name, right? We can have different method name, but if you try to understand the task that all of these methods are doing is to calculate the salary. So the main agenda is to calculate the salary, but just based on the parameters, the way of calculating the salary is getting changed. That is why it is good to have same name, so that we can, just by seeing the method name, I know that this is the agenda, and obviously based on the parameters I do my calculation. So one thing you can see here is that in all the cases the return type is same. So this is where most of the students get confused. In method overloading, the overloading is done based on the parameters. The return type has to be same. So in case the return type is not same, you get a compilation error. Okay, let's see the parameters once again. So in this case we have int base salary, we have just one parameter. In this case we have two parameters, but we have data type as int and float. Here also we have two parameters, but we have data type as int and int. So now we have seen that how do we write same methods again and again. So now since we know what is method overloading, now let's try to understand that how compiler knows that which particular method has to be called. So we know that in order to access a particular method of a particular class, we need to create an object. So for this employee class, we will create an object. So now I have the object emp. Now based on the parameters that we pass, the particular method gets called. So if I pass something like this, emp dot cal cell 20,000. Let me write all the ways first. Okay, so now let's try to understand that which particular call goes to which particular method. So in this case we have emp.calsal. We are giving one parameter which is an integer. So now what will happen? Compiler will check here that which is the parameter, which is the particular method which is receiving just one parameter of data type int. So this is the one. So this particular method gets called. Now in this case we have two parameters, both of them have data type int. So in this case again it will check which of the method has two parameters and both of them have data type int. So this is the one, no. Is this the one? No. It has two parameters, but this is of data type float. So it will go on to check for the one which is having two parameters with data type int. So in this case there are two parameters and both of them are int. So this particular method gets called. Now in this case we have two parameters, one is integer and one is float. So what happens here? The compiler looks for a method which is accepting two parameters, one integer, one float. So this is the one, this is the one. So this method gets called. So this is how method gets called in case of method overloading. Now since we got to understand method overloading, we will go on to try to understand method overriding. Again, since we have already discussed method overriding in inheritance, we will just have a brief revision on it. Now let's try to understand method overriding. So if we try to define method overriding, Method overriding is a scenario in which subclass redefines the same method defined in the parent class. So I'll write it down. If subclass defines the same method defined in parent class, it is known as method overriding. Let's try to see an example for method overriding. So let's say there is a class called car. Let's say car has a method called drive. Let's say it has its own implementation of drive. As of now, let's say we are printing something. Now let's say there is a class called Mercedes which extends car. Now Mercedes wants to have its own implementation of drive. It may happen that whatever implementation is there for the superclass is not sufficient or is not relevant to the child class. So now the child class will have its own implementation of drive. So this is known as method overriding. We have had a good discussion over method overriding in inheritance. I would suggest you to go and see that. So this is what is method overriding. Now in this case, both parent class and child class are defining the same methods. So in case I want to call the child class of drive, there are various ways to do this. So let's say I create an object. So I will create various objects and then we will see that how the method call goes. Okay, so here we have created three objects and we have called drive method in three different ways. So in first case we have a object variable. So this is the object variable. Object variable is of type car and it is referring to an object of car only. So this car is an object variable of car and it is referring to a car only. So in this case when I do car.drive, then this method gets called and car is driving gets printed. So in case 1, car is driving gets printed. Now in case 2, what's happening? That this object variable is of type car but it is pointing to an object of Mercedes. So when I do car.drive, this drive method of Mercedes gets called. I'll repeat this. In this case, this car is an object variable of type car but it is referring to Mercedes. So this is what you can do. So you may get confused that okay, the object variable is of type car but it is referring to Mercedes. It might be an error. It's not an error. You can do this thing in Java. So you have a car variable which is referring to Mercedes object. So in this case when I do car.drive, then the drive method of Mercedes gets called, the drive method of child class that's called, and this Mercedes is driving gets printed. Now there is another case in which our object variable is of type Mercedes and our object variable is pointing to Mercedes only. So in this case again if I call Mercedes.drive, this drive gets called and Mercedes is driving gets printed. So now what happens in Java is that during compile time, The compiler only knows that this particular object variables are of which type. They are of car or they are of Mercedes, but they are not aware that they are pointing to which particular object. So I'll repeat one thing that I have discussed in the previous sessions also. So this is just an object variable. So if I say car, just an object variable car gets created. And when you do new car, then an object car gets created, and this car object variable points to this particular object. So in this case, this car is pointing to car object only. In this case, it is pointing to Mercedes. So this resolution that this particular object variable will be pointing to which particular object is done during runtime. So that is why we have seen that there are two types of polymorphism, runtime and compile time. Method overriding is something which supports runtime polymorphism, and method overloading is something which supports compile time polymorphism. We will try to see that how is this possible. Now we have a bit of idea about runtime. We will see about compile time and we will discuss more on runtime. Before that, we need to understand static binding and dynamic binding. So let's go on to understand that. Now we will try to understand static and dynamic binding, and through this we will also go on to discuss runtime and compile time polymorphism. So first let's try to understand what is binding. So let's say there is a class employee. So let's say there is a method cal salary. Okay, so there is a method cal salary. Now when I create an object of employee, and when I do emp dot cal salary, when I am making this method call, this particular method call will go on to bind to which particular method body. So we have seen now that in case of method overloading, we have multiple methods with same name but different parameters. In method overriding, we have parent is also defining the same method, child is also defining the same method. So whenever I am making a method call, this particular method call is going to attach to which particular method body is known as binding. Now the binding could be static and dynamic. Static binding is when during the compile time only the compiler knows that okay, this particular method has to be called. So static binding is something in which binding is done during compile time. This is also known as early binding. Okay, I'll write time again here. And dynamic is one in which binding is done during runtime. Okay. So we will see that what are the scenarios in which binding is done during compile time or during runtime. So first I will discuss what are the scenarios in which binding is done during runtime. Okay, so let's say in this case we have created employee emp equal to new employee. So during compilation, the compiler only knows that this particular object variable is of what type. So it only knows that emp is of type employee. It does not know that this employee is pointing to new employee, or let's say there is a subclass of employee. Let's say the subclass of employee is programmer. So in case I write something like this, so during compile time, the compiler is only aware of this particular type, that this object variable is of what type, it is of what class. It does not know that this object variable is pointing to which particular object. So in such scenarios, when during compile time, the compiler is not aware of the particular object. So if I am not aware that okay, this employee is pointing to employer programmer, how will I know that I have to calculate, I have to call calculate salary of employer programmer. So in such scenarios, the binding the particular method body is attached during runtime. So that is called as dynamic binding. Now what are the scenarios in which the binding is done during compile time? So in case the object is static, private or final. So if our methods are static, private or final, the binding is done during compile time only. Why? Because we have already seen that static, private and final methods cannot be overridden. So if they are not overridden, so if employee class is having a method that is static, private or final, that cannot be overridden by the subclass. So there is no ambiguity. The compiler knows that okay, if this is static, private or final, it will be defined in this particular type only. So methods which are of static, private or final, they are binded during compile time only. So this is called static binding. And when during compile time, compiler is not aware that which particular method has to be attached, in that case the binding is done during runtime. So this is dynamic binding and static binding. Now we will go on to see runtime polymorphism and compile time polymorphism. Now let's discuss runtime and compile time polymorphism. So the basic difference between compile time and runtime polymorphism is that in case of compile time, which particular method has to be called is decided during compile time only, and in case of runtime, which particular method has to be called is decided during runtime. So let's consider a scenario of method overloading. So method overloading is something that supports compile time polymorphism, and overriding is something that supports runtime polymorphism. We have seen several times, we have actually have had an overview of why we are saying that it supports runtime polymorphism, but we will discuss this again here. So let's say this is a class that is overloaded. We have add method name with 3 different parameters. Now when I create an object of overload and call add, let's see what happens. So whenever we use the object and call the add method during compile time only, the compiler goes and checks that okay, this particular add method, it will first go on to check that if there are multiple add methods. Yes, there are multiple add methods. So then during compile time only, it will go and see that for the given parameters, the parameter that we have passed, which particular method body is appropriate. So this overloading resolution, this is called as overloading resolution, and this is done during compile time only. So whatever is the object variable here, this object variable is of type overload. So the compiler goes to the overload class, checks for methods that are of name add. In case there are multiple methods, it checks that whatever is the appropriate method for the given parameters, that particular method is chosen to be called. And all of these happens during compile time. So method overloading is something that supports compile time polymorphism. So this is a common question that is asked during interviews, that what is the difference between runtime and compile time, and you're asked to tell that how Java supports the two. Now talking about runtime polymorphism, how do method overriding supports runtime polymorphism? So let's try to call the methods in this case. So now we will try to understand method overriding, that how method overriding supports runtime polymorphism. So here we have created 3 objects and we have called this drive method in 3 ways. Now what happens is that during compile time, compiler is only aware that this object variable is of what type. So it is just aware that I am of type car, this car is of type car, and this new car is of type car. Okay, so this is also of type car new. Okay, so during compile time, this particular variable is not aware that I am pointing to which particular object. It is just aware of this particular type, that what is my type. So I'll repeat this. So this is an object variable. This is an object variable. So what happens is that whenever you do this thing, car, an object variable is created. And when you do this thing, new car, a real object of type car, of class car is created, and this object variable refers to this particular object. And during compile time, just this gets created and it is not pointing to any object. So during compile time, these variables are not aware that I am pointing to which particular object. So it is not possible during compile time to conclude that these method calls will be attached to which method body. So that's why these method calls are deferred till the runtime. So runtime, when these objects get created, the exact method calling happens. That is why method overriding is said to support runtime polymorphism. So that was all about polymorphism.